All right. So this is 1.2, analyzing graphs of functions and relations. So we'll see a bunch of graphs today. And yeah, you want to use graphs of functions to estimate function values. And this is something that you've done before. Um, so yeah, let's look at it. Here, we're going to be given this graph, the graph of a function. And you'll see, remember, each point is x comma y. But with functions, they write it as x comma f of x, because remember the f of x and the y are interchangeable there. All right, so yeah. So determining what the x is, you can plug that into the function and you'll get your y value. All right, so it's just telling us our points. All right, and that's that. Let's put down the notes. Here we go. Notes. All right. So use the graph of each function to estimate the indicated function values, then confirm the estimated algebraically, round to the nearest hundredth if necessary. All right, so I won't do all of these. Let's just do maybe one or two. Yeah, and then you can try the rest. Okay, so looks like three has a circle, a green circle. So if you want, you can check the book for that full answer there. So try that out. Um, all right, and remember number four is a piecewise function. Okay, so determining where you're choosing, you want to use that function. Okay, that specific one. So p of -6, -6 is less than 2, so you'd use this one. Here, p of 2 is or equal to 2, so you'd use that t minus 1. Okay, and the same with 9, p of 9. Okay, so just keep that in mind, but I will show you. Let's do, can't think, let's do two. All right, yeah, why don't you try number one? All right, and I'll do number two. So here you first you want to estimate. Okay, estimate, just look at it. What does it look like? So at -2, notice that it's scaled 2, 4, 6, 8, 10. Okay, so our values are scaled. And if you're wondering how do you know it's scaled? Because here this is the second marking from that y-axis, and that's a 4. So 4 divided by 2 is 2. So scaled by 2. All right. So first we want to look at x equals -2. So look at -2 here and go all the way down. And it looks like it's crossing about there at -40. So I'm going to estimate that to be -40. So g of -2 is -40. And g of 1, okay, so go to the 1. So 1 is in between 0 and 2. So it's going to be right there. And is that crossing? Yeah, it looks like it's crossing the x-axis. There you go. I'm going to say that's 0. All right. G of 1 equals 0. And remember, estimates, uh, yeah, it's anybody's guess. So could be right, could be wrong, could be close. G of 8, so go to the 8, and there you go. That is also 0. What in the world? I'm sorry, I guess I got easy ones. Oh well, that's what happens, I guess. All right, so let's plug these in. So they want us to confirm it algebraically. So that means we're going to plug these into the equation, into the function. So here, the first one is g of -2. So we're going to plug in -2 for each of those x's. And remember, especially because it is a -2, you want to put it in parentheses. So -2, -2. All right. So -2 squared is going to give us -2 times -2 is +4. So 4. And then here, remember PEMDAS. You want to do the exponents first and then multiplication. Okay, so do exponents first and then multiplication. So we have -8 times 4 plus 5. And then remember you want to, because of PEMDAS, you want to do multiplication before adding and subtracting. So you get 4 minus 32 plus 5. That's going to give us -23. And that's it. Okay, that doesn't look right. Oh, I guess it's crossing over here. That's a long line. Okay. Yeah, I guess we were way off. Or I was way off. Oh well. I blame it on sleep. So another lesson, sleep is very important. There you go. All right. So, oh, wait a minute. Why did I square it? That's the problem. Okay. I'm sorry. I don't know why I squared it. That one. Ah, this should be cubed. That's the problem. I wish I could edit the video and so you wouldn't see that mistake. But this is another lesson. Everybody makes mistakes. So there you go. Yeah, that should have been a cube. Oh boy. Yeah. All right. So let's change that negative. Let's change that 4. So -2 cubed is going to give us -8. So when you cube a negative, it's going to stay negative. So this is going to become -8. There you go, -8. Minus 32 is going to give us -40. Plus 5 is going to give us -40. Sorry, -35. All right. So yeah, -35. There you go. So do not make sure you get the proper amount of sleep when doing math. It's necessary. All right, and let's look at B, G of 1. So we're going to have 1 cubed plus minus 8 times 1 squared plus 5. 1 cubed, 1 squared. 1 cubed is 1. Minus 1 squared is 1 plus 5. So that's -8. 1 minus 8 is going to give us -7 plus 5 is going to give us -2. And that's it. And it is not 0. So it was close to 0. Again, because it's scaled. So who can tell? And C, G of 8. So we're gonna have a cube minus 8 times 8 squared plus 5. All right, so there you go. And if you're wondering, I had to cube 8, that's going to be a big number. And yeah, actually here we have 8 squared times 8, which is also 8 cubed, but it's minus 8 cubed. So 8 cubed minus 8 cubed cancels out. Yeah, so these two are going to actually cancel each other out. So we basically just have 5. Ta-da! And you can check that on the calculator if you'd like. And that's it. So we were kind of close, I guess. Yeah, ends up being 5, not 0. All right, so do the same thing with number 1. Try it out. If you like to try number 5 as well, that'd be a good one. Okay, try 1 and 5. I'll put these on the notes. Oops. No. There we go. And yeah, so you have a word problem 1, water consumption. Yeah, same thing. Just more realistic numbers, decimals, right? And for this one, oh, actually, maybe we should go over this one because this is you'll see questions like this on tests where you're given a graph and then you have to talk about the year. So it says bottled water consumption from 1977 to 2006 can be modeled using f of x equals 9.35 x squared minus 12.7x plus 541.7, where x represents the number of years since 1977. So that tells us that 1977 is going to be 0. Okay, so right here, this is 1977. Okay, and this is going to be 1977 plus 3. Okay, really common to see this one plus 3, so it's going to be 1980. Okay, 1980, 1977 plus 6. It's going to give us 1983. All right, etc., etc. So that's how they do that. That's how you read it. Okay, and notice here our key, it says these are for millions of gallons. So 1,000 millions of gallons. So 1,000 millions. All right. So there you go. And yeah, use the graph to estimate the amount of bottled water consumed in 1994. 1994, what you want to do is use the graph to estimate. So first, we have to find out what number are we looking at. So we want to look at 1994 minus 1977 to find out what our year is. Okay, and there we get 17. So we want to look at 17 here. So close to the 18, right there. Okay, and again, we're estimating it. So I would say 3,000 million. So what does 3,000 million look like? 3,000, and then you put million there. Whoa, whoa, that's that's 3 billion. There you go. Okay, so that's how you would read that one. So it's actually 3 billion. These are all billions there. Okay, so 3 billion gallons. That's a lot. All right, and then for B, it says find the 1994 consumption algebraically. So not estimating, but algebraically. So it says round to the nearest 10 million gallons. Oh, okay. All right. So again, we're using 17 for X. Okay. So use 17 for X. And we're going to plug it in over here. Let's do it up here. Let's put B here. F of 17. So 9.35 times 17 squared minus 12.7 times 17 plus 541.7. Okay. Oh, 17. 17 parentheses 17 parentheses 17. All right. So I'll do it on Desmos. Let me pause here. All right. So if you plug that into your calculator, all right, make sure to keep in mind those parentheses. You should get, and we're going to put the approximate symbol. Okay. So I got 2027.95. Remember, we're rounding to the nearest 10 million. Okay. So we're rounding to this one, 10 million. Okay, so here it's going to be 3, 0. Then here, because that 7 is greater than 5, we are going to round that up to 3. All right, so 30 million gallons of water. Okay, so what does that mean? That's basically 3.03 billion gallons. Okay, so how do you want to write it? Either way is fine. This is the way the book writes it. All right, that's how you do B. And it says use the graph to estimate whether when water consumption was 6 billion gallons, confirm algebraically. All right, so this one, here we're talking about the 6 billion gallons. So this is not the X, this is the Y value. Okay, that's our output. So here we don't want the X to be 6 billion or 6,000. We want the Y to be 6,000. Okay, so here we go. Let's do it here. So we write our function, 9.35 x squared. Oh, sorry, it's estimating. Huh, huh, huh. Gonna have to do algebraically. Whew, I was getting nervous. All right, so we want to look at the graph. Look at the graph at 6,000. And go to the right to the graph. All right, so we're gonna check to see, go down. And there we go. It's in between 24 and 27. So I would say that's about 25. So X equals 25 years. Okay. Or 1977 plus 25 gives us 2002. All right. But then I just saw it just say algebraically. Okay, let's do it. So we're gonna write down that 6,000 equals, and then we just put the function there, 9.35 x squared minus 12.7 x plus 541.7. All right, so here, to solve this, yeah, you're not going to factor that. What we have to do is we have to set it equal to 0 first. So we're going to set it equal to 0. Okay, so we're going to subtract 6,000 from both sides. And our constant is right there. All right, that's an equal sign. I'm sorry. All right, so there we get 9.35x squared minus 12.7x minus 5,458.3. Whew. All right, and it equals 0. So since it equals 0, how do you solve a quadratic? The quadratic formula. All right. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Spirit fingers. Okay, so here, this is our a, 9.35. This is our b, negative 12.7. This is our c, negative 5,458.3. So plug all of those in. Yeah, this is why I was not happy with the algebra. But this is what we get sometimes. So minus negative 12.7. But negative is going to cancel out. Plus or minus the square root of b, so negative 12.7 squared minus 4 times our a is 9.35 times c, negative 5,458.3 all over 2 times a 9.35. All right, now here, just calculate it. Okay, just use your calculator for this one. I'm going to pause it and you try to get the same answer as well. Okay. All right. So as you were putting that into the calculator, you're probably wondering, how do you put that plus or minus? You have to do it 2 times. Okay. So one time you put a plus, so negative 12.7 plus square root, blah, 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 over 2 times 9.35. And then you had to do another one, negative 12.7 minus square root of blah, 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 all over 2 times 9.35. So you have to do it one at a time. And when you do positive, the plus, you get 24.83, sorry, 85. When you do negative, when you do the minus sign, you get negative 23.49. Now, we can't have that negative year, okay, because that was in the past. We're looking at the future. Yeah. So here, what we get is 24.85. All right. Or you can add that to 1977. You'll get 2001.85. So in between 2001 and 2002. All right. So close enough. And I guess that's it. So let's look at some more tomorrow.